My name is Silvio Data. I'm the Senior Fellow of Vehicle Dynamics in Stellantis Global. Thank you for attending the presentation, and let's start. The approach of Stellantis at vehicle objective evaluation on vehicle dynamics and virtualization is well established, was presented several times in these and other conferences. I remember my first presentation in Visita 1995 when I presented the objective evaluation of the steering feeling. And then year by year, we are presented what we are doing. And just yesterday, Andrea presented the integration of the hardware in the loop of the shock absorber on the simulator that, as far as we know, is the first worldwide application of this technology. And we are proceeding in this direction. What we are presenting today is something that apparently can seem very basic, but in reality, it isn't. We are talking regarding tire wearing. Tire wearing approach in Stellantis, but in many OEMs, is to delegate a lot to the supplier, defining the target, and making a final check at the end of the development. This usually works, but we have some issue recently, especially with some newcomer suppliers. And then we are evaluating to change something in order to introduce intermediate check. But unfortunately, it's not possible to use what we do at the end in intermediate because it has a long duration, has high cost, and then it becomes complex. Then what we are trying to do, we are investigating, is to use something that is simpler, but let to make an early prediction of the tire wearing using a smart procedure, even if we are conscious that these have a reasonable precision. What we mean as reasonable, just to give an idea, is something around 10–15% of relative position as a respect to a reference tire, then in a relative way. We started an investigation with several potential partners, and we identify in MegaRide an approach that potentially can fit very well our expectation. And then we started with a proof of concept project with Flavio team. And Flavio, please.
Thanks. Thanks so much, Silvio, for the introduction to the activity. Just a few words about who we are. Stellantis does not need specific introduction. Maybe we do. We are, first of all, a research group at University of Naples. We work from about 15 years in vehicle dynamics. In 2016, we founded our first company, MegaRide. Then we acquired the second one, and then a few other startups were born within the group. So now we are 4 companies. We involve about 60 people, with 18 PhD funded within the companies. And we were born with motorsport, so we work within 13 racing series with more than 35 racing teams. But we are expanding this kind of technological platform to OEMs and tire manufacturers, which nowadays use this kind of methodologies. Today, we are going to introduce how we applied some of the tools we developed within this case study. Our platform is called Ride Suite. It's a multi-physical and modular platform regarding tire simulations. It has a thermal module, ThermoRide, a multi-contact ride module, 3D Ride, an advanced MF-EVO interaction module, Other Ride, and the Wear module, where the first commercial wear and degradation module, Wear Ride. Each user can select which module he wants to use within his daily activities. The key features of this kind of approach and the peculiarities of our approach is that we want to be smart. We were born with motorsport. Our characteristics is that our model have to be parameterized and calibrated in a smart way. So we are perfectly fitting the event we are representing today. And we want to be something different because with simple and non-destructive tests, you must be able to parameterize your own simulations with always the same analytical formulation within each of these models. And you can use both in desktop and DIL applications. Today, for these specific projects, we will introduce you a couple of modules we selected for this target. The thermal module, ThermoRide, and the Wear module, WearRide. This one, as said, is the first commercial wear and degradation tire model. It was awarded by Vehicle Dynamics International Award in 2024, and it's based on an advanced physical approach which is linked to the stress-strain distribution within the tread blocks linked to the damage theory. So we developed the stress strain formulation within the thread block, and we apply this to the damage factor, which lap by lap and kilometer by kilometer accumulates, of course, the damage within the tire itself. The key features of this model are that everything has to be parameterized with completely non-destructive testings. Road roughness plays a very deep role, as we know, in wear and degradation, and we have some proprietary applications to develop this kind of analysis. And we feel how thermal module and footprint shapes act within the wear and degradation effects and factors. The target of the model is to have a tire tread wear as applied both in the mechanical degradation and the progressive tread thickness reduction. And this model is linked to road roughness and thermal applications. This is, in our opinion, very important also with the paradigm shift which is coming in our lives linked to Euro 7 regulations. And so probably in few months of years, we will be here talking about what Euro 7 is going to mean for all of us. The roadmap and the pipeline of the activity was based on VI-CarRealTime simulations at the beginning with a validated model by Stellantis. In parallel, our group developed the parameterization and the non-destructive test of the tire itself, and finally we ran our simulations with the ride suite modules. Silvio will explain us in a minute how they did the job on the vehicle model and on the road missions linked to the wear test. We will explain you how we developed the viscoelastic characterization and structural characterization of the tire and the road roughness analysis from the mission and the path the activity developed. And finally, we will run some of the results of the activity. Please, Silvio. Sorry, back.
Oh, yes. Then let's start with the activity. Consider that all this activity started in December.
Yeah.
Then we are talking not of something done 1 year ago and so on, but in a short time, really in a short time. First step was the definition of the test case, considering two boundary conditions. We wanted to select something that we had available. Then we selected on the library of the test that we have performed recently on the road. Second condition, to have the availability of the model. This is not a big issue because we have a full coverage of the virtual model on our portfolio. We decided in this case to have also because sometimes the problem is to have the measurement, because we measure the basic configuration of the vehicle and all the variants are in virtual. In this case, we prefer to have something that was also measured. Then the model that we had in multi-body environment was fully validated in static and dynamic condition, and we extracted the input to build the VI-CarRealTime model that we intend to use to run the simulation. In this way, we selected 3 test cases to apply the methodology. First step was to make the simulation, then to use the GPS data, real GPS data coming from the test to reproduce in virtual and 1 day driving cycle, to a total of 250 kilometers, roughly. It worked quite well. We had just some issues related to the GPS incoherence in some parts, and then we needed to perform some correction, but in general, it was a good reproduction of the lateral and longitudinal acceleration, and this led to build the panel of the information that are needed for the following step of the methodology. Then vertical load, camber, longitudinal lateral slip in each of the wheel. This was the set of data that we passed to start the tire wearing simulation. We are fully aware that in the future, these two phases can be merged, having the wearing simulation embedded in Kjær real-time simulation. In this proof of concept, we decided to divide it into 2 parts, but this was just in order to speed up and divide the responsibility between our 2 companies. Yeah. Please. Flavio.
Thanks. And so, in the meanwhile, our friends in Stellantis were developing the vehicle simulations. We were doing our job on the tire. The first thing to do was about characterizing the viscoelasticity of the tread of the tire. We developed a few years ago for motorsport this technology called Vesevo. You can have a demo at our booth in the expo area. It's a device which is able, in a very fast and non-destructive way, with a very simple test, to get the global assessment of the tire viscoelasticity characterizations, which means the storage modulus and the loss factor. It's a sort of DMA portable machine. For the activity, the 3 tire specs were characterized, and as you can see, spec A, B, and C provided very different and interesting characteristics in terms of the elastic and viscous behavior in terms of viscoelasticity of the tires themselves. In parallel, we did the job regarding the tire footprints. So at our lab, we developed this, once again, non-destructive test concerning tires. So with our press and with this pressure-sensitive carpet by TechScan, we are able to provide the footprint shapes of the tire under different camber angle, vertical load, and inflation pressure characteristics, because the area of the footprint, of course, is the area through which the energies linked to the wear model pass. Third part, very important, was linked to the road roughness characterizations. In this project, we got the data about the geographical area where the missions had been carried out from our historical database, because in MegaRide we have several different road roughness scans from all around the world. But in general, our group in the last year, thanks to experiences in motorsport, were able to get proprietary evaluation and methodologies to get information from 2D or 3D road profiles and to get important KPIs which are deeply linked to friction, grip evaluation, and of course, wear and degradation phenomena. Coming to the results. On the left side, you will see the results of the experimental campaign which Silvio showed you at the beginning. So 3 actual cars with 3 different actual tire sets run in a specific mission on a certain route. On the right side, you see the 4 tires for the 4 corners for the 3 specs. Actually, the simulations by VI-CarRealTime were able to predict the fact that the spec B was the one which were more and which reached before than the other ones the legal limit for which the front axle is at the limit of its predicted wear expectation. The rear axle, so in the below area of the diagram, had less wear, and so it was confirmed also by the experimental data you see on the left side. So we have that the B spec was worse than the C spec, than the A1, and A and C were quite similar. So it's a predictive and preliminary assessment of the tire suppliers before eventually of the actual outdoor runs. The model is able also to work in local. So the model was able to predict that on the width of the tire, which was the shape of the wear profile. And we once again got the fact that the most worn tire, so the spec B, had this kind of shape of the tread. And what does it mean? In this kind of missions and routes, the wear and degradation phenomena were linked to rolling phenomena and not much to handling ones. And so for this reason, the most worn area is the area at the center of the tread, because of course we are wearing the center part of the tread itself. And once again, it's confirmed the fact that front axle was wearing more than the rear one. So the model was able to catch also this kind of results. After this quick analysis, I would leave to Silvio the conclusions about the study.
Yes. At the end, I don't repeat the scope of the activity. I think it was quite clear. And focusing on the results, the approach sounds very promising, can catch well our needs. We know that we have some aspects that we still need to work, and this can be done in 2 directions, to work in the way of the simulation or to change some of the assumptions that we had, introducing a little more complication in our approach, such as example, characterization of the road roughness, tread viscoelasticity degradation during the test, and other points that Flavio can explain better than us. But in general terms, the approach, the proof of concept was positive, the approach is very promising, and we intend to proceed in this direction according to the next step. That please, Flavio.
Yeah, so this project was really nice. We were really encouraged by the results. And as said, I think, and we think that these kind of things could lead us towards what's going to happen within the Euro 7 big wave, which is going to come on us. In this project, the thermal characterization and road roughness, as Silvio was saying, were a little bit simplified. We will have probably a second step of the proof of concept in which the road roughness and thermodynamics will be actually characterized on the actual tires and on the actual route. All what we did in desktop simulations will be soon on the DIL in Stellantis, and you can also try the same technologies at the DIM 400 session, which is here, or on the driving simulator we have here at our expo area together with the Meccanica 42, in which you will feel thermal dynamics, multi-contact dynamics, and wear dynamics. And finally, all the activities will be within a PhD path jointly coordinated by Stellantis, MegaRide, and Unina, in which we aim to adopt this time multiphysics within simulation activities for several different scopes. Thanks for your interest.
Thank you very much.